Lesson 8.9 is talking about end behavior from graphs and algebraically figuring out what the ends are doing. And so the concept of the end behavior is simple, but writing it out sometimes can be tricky. So in number 1, we have a polynomial graph that has lots of curves in it. We don't care about anything in the middle. When I say end behavior, I'm simply talking about the ends that have the arrows. So what is this end doing? What is this end doing? And you might say, well, this end's going down. It is, but what are x values doing as it's going down? And so I would read this graph two-dimensionally saying, okay, this side, the x's are going to get smaller because here's going to be a point when x is -9. Here's going to be a point when x is -10, right? It keeps going. Sorry, that's not very good. But it's going at an angle where x's are getting smaller and y's are getting smaller. So what I write is as x, you put an arrow for goes to, when x's are getting smaller and smaller and smaller, you say -infinity, comma, y's, but we're going to say f of x, fancy way for writing y, y's are also getting smaller. So I would say goes to -infinity. So this makes this end go down here in quadrant 3 where it's x's are negative and y's are negative. Okay, the other end up here, these are as x's are getting bigger, right? This is x is like 3.5, and then at 4 it would be higher, and 5 it would be higher, and 6 it would be higher. So as x's are getting bigger, y's are getting bigger. So positive, positive in quadrant 1. So I'd write as x goes to infinity, y or f of x goes to infinity. Okay, number 2, I see both ends are pointing down. So this side is as x is getting smaller, it's going down, the y's are getting more negative. So I would say as x goes to -infinity, f of x goes to -infinity. This end, as x's are getting bigger, the y's at those points are going to keep getting smaller. So that tells me that the left and right ends are both going in the negative direction. All right, but what if we have no graph, just an equation? Well, there's going to be a pattern to these. All you really need to know is the leading term, which is the highest degree term you see. Remember writing it in standard form, so I'm just going to pick out what's the highest exponent would be this guy, -3x to the 5th. That's all I need to know to be able to figure this out. And so what happens when I have an odd power or odd degree, the end behavior is going to go in opposite directions. So it's either going to go one end up and one end down, or one end down and one end up. And the way you're going to know is based on the leading term, leading coefficient, sorry, that's a negative. And so think about negative slope. It goes downhill over time. You want to end up going down. So we read a graph from left to right. So really what I'm saying is the right side should be ending up going down. Because even though this arrow looks like it's pointing up, it's coming from the top and decreasing and then doing some curves in the middle and then still going down. So if you're riding a roller coaster, it's decreasing. But anyhow, so if I see this and I see odd power and a negative, that means it's starting up high and then going down the whole time. Okay, so if I want to write end behavior like I did here, this would be the as x goes to the left or -infinity. The y's are going to keep increasing. And then this guy would be as x's are getting bigger because they're going to the right, f of x would be getting smaller because it's going down. Okay, number 4, pick out the highest degree term. It would be this 5x cubed. So again, it's going to be one end up, one end down. And this is a positive 5, so it's going to end up going up. So it's going to start down, go up. In the middle, we don't care how many times it curves or whatever, but we just care about the ends. So this end here would be as x is going to the left, x gets smaller, y gets smaller, x gets smaller, y gets smaller, x gets smaller, y gets smaller. Okay, and then this end, as x gets bigger, y gets bigger, x gets bigger, y gets bigger. Okay, and then number 5, we have the highest term is this 9x to the 4th. So when it's an even power, they either are both up or both down. They go in the same direction. And then if it's a positive coefficient, that means they're both up. So this function has end behavior like this. Again, we don't care what it does in the middle. We just care about the ends. So this one would be as x gets smaller, y gets bigger. And this end over here, as x gets bigger, y gets bigger. All right, and then the last one is the only other option where it's an even degree, but the leading number is negative. That means they're both going to be down. So again, I don't care what's happening in the middle. It can be as crazy as you want. I care about these. So as x gets smaller, y's get smaller. As x gets bigger, y still gets smaller. Okay, and then I made a little table down here if this helps you at all. So if it's an even power, having something like x to the 4th, a positive coefficient, so having, say, 3x to the 4th, is going to have both ends up. If it's an even power but a negative coefficient, say like negative 3x to the 4th, both ends are going to be pointing down. If it's an odd power, let's say 3x to the 5th, and it's a positive coefficient, that means that one end's up, one end's down. We need to end up up. So the other end starts down. It goes like this. But it's kind of increasing the whole time like a roller coaster. And then a negative coefficient with an odd power would mean you got to end up going down. So it does this, where you're decreasing the whole time.